Good day, class, and welcome back to ESI 124N, your engineering mechanics 2 or your dynamics of rigid bodies. And for today's lesson is your lesson 5, the kinetics of a particle, your force and acceleration. So in this lesson, basically, we will deal with the relationship between the change in motion of a body and the forces that cause these changes. But before we proceed for our main lesson for today, let's just have a quick recap or say what are the mga main idea that I have shared to you, mga lessons sa lesson 4. So basically, ang lesson 4 is about the planar kinematics of a rigid body. And we did discuss three main parts there. So first is your planar um, motion of a rigid body. What is the planar motion of a rigid body? Next is your translation, and lastly your rotation about the fixed axis. So in that lessons, we actually did learn on how to discuss the principle of planar kinematics of rigid body, and yeah, somehow we explained the planar rigid body motion, and we did uh, define that planar rigid body motion is the basically the movement of a part of the particles in a body, which is equidistant to each other in a fixed plane, no? And then also we did uh, further discuss na meron palang tatlong types of planar motion. Your translation, uh, your rotation about the fixed axis, and a combination of two, the general plane motion. So in translation, no, nalaman natin ay composed pala nito two types of translation. If your particle moves in a straight line, or rectilinear translation, and if your particle moves in a curvilinear or curved paths, no, that's what you call a curvilinear translation. And for your rotation about the fixed axis, no, dinescribe din natin on what are the concept behind the rotation about the fixed axis, the particle. And we did discover that there are actually called angular motion. No? Mga angular motion natin is the angular position, angular displacement, angular velocity, and angular of acceleration. And also, after we discover those angular motion, we then solve problems about the rotation about the fixed axis of a particle. And also, we did learn na pwede palang makuha yung velocity sa isang, let's say, gear, pulleys, um, other, basta mga bagay or like mga machines that moves in a circular path. So, yun, we did learn na pwede pa lang masolve yung velocity gamit yung angular motion ng mga angular velocity, angular acceleration, and so on. So, I think that's all for the lesson 4, no? Yung mga summary natin on previous lesson. So, let's proceed. So, for your lesson for today, these are the contents. So, first is this Newton's second law of motion, the equation of motion, the equation of motion of a system of particles, and lastly, the equation of motion using rectangular coordinates and the normal and tangential coordinates. Though it's this one is very familiar now since we did discuss this um, normal and tangential sa dalawang lesson natin sa curvilinear and the rotation about the fixed axis. But anyways, these are your learning outcomes. So you must be able to explain the Newton's second law of motion, discuss the equation of motion, derive the equations of motion for a system of particles, derive and explain the equations of motion using rectangular coordinates, derive and explain the equation of motion using normal and tangential coordinates, and of course, di mawawala yung pag-solve natin sa mga problems related to Newton's second law of motion, equation of motion using rectangular, normal, and tangential coordinates. So, uh, let's proceed for our part 1 of this lesson. So, for the part 1, we're going to discuss about the Newton's second law of motion. So, we all know that Newton's laws of motion, that there are three, no? And then the second law states the um, actually, di ba, na-discuss natin sa natin, mga introduction of the introduction of dynamics that there are three. O hindi talaga sa dynamics mismo na-discuss, but in your previous mga courses like the statics, you did na siguro, and then in your senior high school. So, kinetics is a branch of dynamics that deals the relationship between the change in motion of a body and the forces that causes this change. So, again, in touch na tayo sa kinetics. And this actually point of our point of say sa dynamics is, and yeah, pumasok na si forces. And we are going to, consider na the forces that causes those changes. So that's your kinetics. Okay? So the basis for the kinetics is Newton's second law. Kaya kailangan natin ma-understand yung concept of second law motion so that we can also internalize, ma-realize natin kung ano ba tong kinetics. No? So, the basis for kinetics is Newton's second law, which states that when an unbalanced force acts on a particle or body, it will accelerate in the direction of the force with the magnitude that is proportional to the force. So, uh, sa madaling salita, mag-move yung object mo na initially at rest kung, if you're going to put some forces on it. And then it will stop also if there are forces or external forces that will act on the opposite direction of the movement. So, ganun lang basically ang second law. No? Kung may unbalanced force na mag-act sa particle ng body, it will accelerate in the direction of the force. Kumbaga, yung main dito is, yung main concept na kailangan ma-understand natin is the direction of the movement of our body is, yes, along with the force, along with the application of the force. Kumbaga, kung pupuntang right, then right din yung basically in real life talaga, no? If you push a car forward, syempre mag-forward yun. Ilain na po, iba naman kung magba-backward kung i-push mo forward. Unless if inclined yung plane mo. Pero kung plane lang talaga, syempre, in Newton's second law states that if an unbalanced force acts on a body, it will accelerate in the direction of the force. Dami ko nang sinasabi. Basta yun na yan. You guess yun na yun. So it's written in mathematical form, force is equals mass times acceleration. And so you can also observe that force is directly proportional to the acceleration. So kung malakas yung force na in-apply mo, then it will, you probably change its acceleration. So since the force and acceleration are directly proportional, the constant of proportionality m can be determined, of course, simply F over A. Okay. Ganun lang kasimple kung para makuha mo yung mass na object na pinupush mo. Okay? So, in that, the positive scalar m is what we call the mass of the particle of the body. And we all know what is mass, di ba? And mass is constant during any acceleration, and it provides a quantitative measure of the resistance of the particle to change in its velocity, which is called inertia. Kumbaga, basically, a mass is, amount of resistance. Kung like, just say, tinutulak ka ng kapatid mo na maliit, you will never be moved unless if ma-counter or I'll say ma what's term ma matutulak ka talagang malakas, like yung yung weight mo sa force and apply niya, syempre move ka of greater than your weight ng force na in-exert mo sa kanya is that basically yung weight mo is the resistance, no? Yung resistance na uh, resistance to for you to move, di ba? That's kumbaga your weight is basically the resistance of your body to not move of a certain applied force. Ayun. Okay? Ganun na kasimple ang pag-understand ng mass. Anyways, so and formulation of the Newton's law of gravitational attraction is force is equals to G times M sub 1 times M sub 2 all over R squared. So where F is the force of gravitation between two particles. G, your capital G, is the universal constant of gravitation, which is equals to 66.73 times 10 to the negative 12 cubic meter per kilogram second squared. And your M sub 1 and M sub 2, the masses of your each of the two particles. R is the distance between the two particles. Kumbaga, yun lang kadali yung gravitational acceleration. So, weight of a particle of body, and we all know that it is computed by W is equals to mass times the gravitational acceleration. So, comparing F is equals to mass times acceleration, with equation above, we use G and no instead no the acceleration due to gravity. Kumbaga, ito lang yung weight, kung paano compute yung weight. And acceleration due to gravity is measured at a point, take note, on a surface of the Earth at sea level and a latitude of 45 degrees, which is considered the standard location. So mag-iiba-iba yung gravitational acceleration mo if above sea level, below sea level, ganun. Okay? And the values of G can be in for SI system of units, that's 9.81 meters per second squared. And your for FPS or US customary system of units, G is equal to 32.2 feet per second squared. Okay, and all in place. So the unit of the unit of weight can be weight is equal to mass times acceleration due to gravity. That's the Newton or N, when if is a unit, and where M is equal to kilograms or or and then your acceleration due to gravity is 9.81 meters per second square. And your weight, unit of your weight will be pounds if you're going to use slugs per second, and 32.2 feet per second square for your gravitational acceleration. Okay, so let's have an example for yeah how to compute your weight using the mass. Okay, find the weight of the stone having a mass of 5 kilograms. So given is the mass, which is 5 kilograms, and required is weight of the stone. And solutions, and napakasimple lang, which is mass times gravitational acceleration, which is 5 times 9.81. So that will be in Newton, 49.05. So very basic. Example number two naman. So, a man weighs 150 pounds on Earth at sea level. Calculate its mass in slug. So, given is the weight, 150 pounds. And then, and kumbaga class, if the problem states, or a man or any object weighs, automatically, that's your weight. Okay? And then mass of the man, ang required natin dito, so, before calculating this formula, is equals to mass is equals to weight over G. So that would be 150 pounds divided by 32.2 feet per second squared. So we'll call me slugs. Okay, those mass is equals to 4.66 slugs. So that's how you basically how to compute um your weight. So part two, the equation of motion. So ano ba itong equation of motion na to? So, equation of motion, when more than one force acts on a particle, the resultant force is determined by a vector summation of all forces. That is, resultant force is equals to the summation of all the forces acting on the particle. So, then the equation of motion can be written as summation of all forces is equals to mass times acceleration. So, acceleration, we all know this one, diba? Sa previous lesson natin, or previous topic. Okay? So, equation of motion states that consider the particle shown in the figure, which has a mass and mass m and is subjected to the action of two forces, F sub 1 and F sub 2. Ito, kumbaga, dalawang forces yung nag-act sa particle natin, itong blue circle here. And then, the direction of its acceleration is left. Okay? So, we can graphically account for the magnitude and direction of each forces acting on the particle by drawing the particle's free body diagram. So this is what you call the free body diagram and the kinetic diagram. Basically, ang kinetic diagram is where your resultant force will or the direction, no? Kung asan pupunta yung particle mo given sa free body diagram. So basically, yeah, just have to draw a line and then arrow kung saan siya pupunta. So, sa free body diagram ng ano natin, sa particle natin dito is this one. So, meron kang force, no? Your first force, second force, and to compute for their resultant force is, yes, specifically, use the Pythagorean theorem, and then you can solve for your summation of all forces is how you solve for your resultant forces, or yeah, basically the whole um, force na nag-act talaga sa particle in accounts its components, its vertical and horizontal components sa F sub 2, F sub 1, and then you add those forces and then find the resultant force. Basically, it's just showing this kung paano natin i-analyze yung particle natin if maraming forces na nag-act sa kanya using free body diagram para ma yeah, graphically we can understand kung ano nangyayari sa particle natin using free body diagram. Okay. So since the resultant of the forces F sub 1 and F sub 2 produces the vector M times A, its magnitude and direction can be represented graphically on the kinetic diagram shown in figure B. Ito yung kinetic diagram, kumbaga ito yung direction ng ano natin particle after it exerted with two forces. So the equal sign is in the figure B symbolizes the graphical equivalency between the free body diagram and kinetic diagram. Kumbaga, yeah, ito yung equivalent ng kinetic diagram ng free body diagram mo. Kumbaga, same lang yung concept when drawing these two diagrams. Okay. So when applying the equation of motion, it is important that the acceleration of the particle be measured with respect to a reference frame that is either fixed or translates with a constant velocity. Consider this figure. Kumbaga, kung mag-solve that, kung apply natin yung equation of motion is all forces acting on the particle is equals to mass times acceleration, is that we need to have a reference frame, no? Itong reference frame natin, inertial frame, papunta to yung movement natin to the path of the particle is that we need, kumbaga, kailangan natin ng reference na either fixed or translate with a constant velocity. Kumbaga, yung there's nothing movement at all kasi nga yung acceleration, if the constant velocity, uh, walang ibang nag-exert or to, kumbaga, magkakos ng particle natin to move or either decrease or increase the velocity. Okay? When we say constant velocity, we learn that there's no acceleration happening. Kasi nga, constant yung velocity. Final velocity minus initial velocity is same, so that will be zero. So there's no acceleration or deceleration at all. So, kumbaga, yeah, uh, there's nothing to change the motion or the static state of our particle. Kumbaga, we need that reference so that we can compute for our forces or acceleration. Ano bang kailangan na acceleration of force for this object to move or change its velocity. Okay? Kumbaga, ang thought na dito is we need a reference frame or axis. Okay? So such reference frame is commonly known as Newtonian or inertial reference frame. Yan to. Kumbaga, ito lang. Kumbaga yung inertial frame of reference. Okay? So, that's all for the equation of motion and then for a particle. So, what if system of particles na siya? Composed of many particles na. So, how to solve for the equation of motion there? So, equation of motion for a system of particles. In a system of particles, isolated with an enclosed region in space, shown in the figure, consider the arbitrary ith particle. So, ito yung ith particle natin sa enclosed region ng, yeah, mga particles natin. So, maraming particles yan. So, yun nga, we say system of particles means that there's a lot of particles inside that enclosed region. But let's focus for this ith particle. Okay? So at the instant, consider the ith particle having a mass m sub I is subjected to a system of internal forces and a resultant external force. So, kumbaga, yung particle mo is kumbaga, meron siyang dalawang forces na nag-cause to move this particle inside in your enclosed region. Your internal force and external. So, again, basically, yun lang yung mga forces na nag-cause or nag-exert sa particle natin. Okay, that's your external force, your capital F, and internal force, your small letter f. Okay, so let's denote that the internal force simply as F sub I, or small letter f sub I. Okay, so the internal force F sub I is the resultant of all forces the other particles in the system exerts on the ith particle. Kumbaga, mga mga particles na to is meron silang uh, action or a force na ini-exert sa ith particle natin. So that's your internal forces. So marami particle dito, therefore marami ding mga internal forces na nag-act sa ith particle natin. So yeah, we need to have the resultant of that all forces or internal forces. Okay? So for external forces naman, let's denote it symbolically as F, capital letter F sub I. Okay? So the external force or resultant external force, F sub I, represents either the effect of gravitational, electrical, magnetic, or contact forces between the earth particle and adjacent bodies or particles not included within the system. Kumbaga, yeah, ang external forces is if outside nasa enclosed region natin na kumbaga, yun nga, in-state natin doon na kinds of external forces that will act to your ith particle will be your may your my gravitational or electrical, magnetic, or contact forces na outside sa enclosed region natin. So we call that the external forces. Okay? So to analyze the forces acting on the ith particle, we must construct a free body diagram and kinetic diagram. So, baga, instruct natin yung ith particle sa closed system natin or closed region natin to this one para ma-analyze natin more likely exclusively. Ito lang talaga yung ith particle natin. So, after we remove, ito pala yung free body diagram niya. So, dalawang forces na nag-act was what have we discussed earlier. Your external force, your capital letter F sub I, and your internal force, small letter f sub I. This is your free body diagram, and your kinetic diagram will be this one. So, papunta pala sa uh, pababa. Pa left konti sa baba. Yan. Kumbaga sa third quadrant of our radiation length. Siya mag-move. Okay? So, ito pala yung reaction ng ano mo, ice particle mo after it then uh, yeah, exerted by these forces. So applying the equation motion, we have all forces acts on the particle or ice particle will be equal to mass times acceleration. So i-add lang natin yung dalawa kasi ito lang yung forces na nag-act sa ice particle natin. So that would be equal to mass of the ice particle times the acceleration of our ice particle. So ayan. So with the equation of motion, so ito lang pa yung pag-compute ng ano mo. Either if asan yung equation of motion, kumbaga, yeah, kumbaga, yung idea lang dito class is, ano ba yung equation of motion ng particle natin when it is subjected into two kinds of forces sa internal and external. So ano ba yung equation of motion basically? So equation of motion basically yung system of particles is each particle has this equation of motion of this one. The external forces of that particle plus internal forces that acts or subjected to that particle will be equal to the particle's mass and the particle's acceleration. Kumbaga, ito lang basically yung equation of motion for a system of particles. Kasi kung particles lang siya, either wala siyang internal or wala siyang external. So, kumbaga, ang idea lang dito class is what if systems of particles natin na sa isang closed region. So, each particles pala, ito pala yung equation of motion niya. So, that will be, again, external forces plus the internal forces is equals to the mass of the particle and acceleration of that particle. So, basically, ito lang yan. Ito lang yung equation of motion na hinahanap natin. So, when the equation of motion is applied to each of the other particles of the system, similar equation will result using equation 5.3.1. So, eto, kumbaga. So, kung kukunin naman natin yung ibang particles or yung kukunin naman natin yung equation ng mga equation of motion sa ibang particles na nasa system natin, same lang or similar lang yung equation na makukuha natin, no? Katulad lang ng ith particle na in-analyze natin kanina. So if all these equation are added together vectorially since they are vector quantities, so we obtain eto pala yun. So, kumbaga, sa isang system natin, ito yung equation of motion sa lahat ng particles of that system. So, that will be all forces or all external forces plus all of the internal forces that will be equal to the summation of the mass of all the masses of our particles inside our system times the acceleration of each particles. So ito pala yung equation of motion sa ating buong system ng mga particles natin. So that will be the summation of external forces plus summation of our internal forces equals to summation of the mass times acceleration. Okay, so if we solve for the summation of internal forces, it will be equal to 0. Since internal forces between any two particles in a system occur in equal but opposite collinear pairs. Sa madaling salita, class, yung mga actions and reactions na natin, each particle sa inside that closed system is, yeah, basically equilibrium lang lahat. Say, if this particle, say, in-exert sa kabilang particle, mag-exert din yung kabilang particle sa ano natin with the same magnitude of force. So, if same magnitude but opposite in direction, therefore, that will be, if we get the summation, that will be negative. Kunwari, the magnitude na exert ang particle natin is 100 Newton, and then 100 Newton then sa kabila, that will be positive 100 Newtons minus 100 Newtons. So, summation nilang dalawa is 0. Basically, walang internal force na ano natin sa whole system lang ha. So whole system. Kasi nga, same lang yung magnitude na in-exert ng mga particles. But, opposite. So, if we find the summation, negative plus or negative 100 Newton plus 100 Newton, that will be equal to 0. Okay. So if all these equations are added together vectorially, we obtain, ayan, so this equation 5.3.2 becomes this one, maganto na lang siya. Kasi nga, we did mention na walang internal forces sa lahat or sa buong system natin. Okay? Sa buong system, pinag-uusapan natin dito class. So therefore, wala pa lang internal forces na account pagkuha natin sa mga magnitudes or basically the vector of that system. Ano ba yung equation of motion sa system na yun? So, we did discover na wala pala siyang internal forces. So, natira na lang is the summation of the external forces is equal to the summation of all of the mass and the acceleration. Okay. So, from the figure this one, Okay, if r sub g is a position vector which locates the center of the mass, g, of the particles, then by using the definition of center of mass, ayan, so sabi daw dito yung center of mass sa buong system natin is has a position vector r sub g. So, paano ba siya kukunin? So, r sub g now will be equal to mass times r sub g is equal to the summation of mass times r sub I. Okay? Kumbaga, yung position vector na nilocate natin sa buong system natin is mass times r sub g is equal to summation of all forces or all forces summation of mass times each r sub I, or yeah, the distance of the particle to the origin, kumbaga. Okay, so that's how you solve for your position vector, sa center of mass natin sa ating system. Okay, so r sub I is the position of the particles with respect to the origin, and m is equal to summation of m sub I as the total mass of all the particles. So, ganun lang pala pagkuha ng position vector ng center of mass natin. No? So, taking the second time derivative of the equation 5.3.4, which is this one, if we differentiate that two times, and assuming that the mass is constant or no mass is entering or leaving the system, ayan, we have, ayan, so mass is equals, ayan nga, diba, nalaman, we did learn na if we did learn na ang second time derivative of the position is acceleration, diba? We all know that from the previous, previous lesson. So, therefore, the second time derivative of the position will be equal to the acceleration, diba? So, constant lang yung mass, so that will be m times acceleration sub g is equals to summation of mass times acceleration. Ayan, so ganito na siya pag second time derivative na natin sa position vector na nakuha natin from the equation 5.3.4. So after we apply differentiation two times, so ito na yung result natin sa ating equation of motion. So note that in kinematics, the second time derivative of position, in this case, r sub g and r sub I, that will be the acceleration. So you can also observe na naging a sub I na yung r sub I natin. So basically, to solve for our acceleration for our mass, or no, the center of mass is this one. So mass times acceleration of uh, center of mass is equals to the summation of mass sub I, or the mass of all the particles times acceleration. Okay. So, substituting equation 5.3.5 to equation 5.3.3, we have, ito yung, natin, kumbaga, equation 5.3.3, diba, yung yung na zero yung internal force, so ito yung, natin, first equation, and then, f sub I, diba, we did learn na, ito yung, ang equal lang na to is mass times acceleration sub g, di ba? Sa equation 5.3.5, you can observe here. Ayan, so mass times a sub g is equals to the summation of m sub I times a sub I. Since sa equation 5.3.3 natin is eto, and we learned that meron tong value or equal. So substitute natin yung equation sa 5.3.5, ito na lang yung mangyayari. So, ang summation of all external forces is equals to now mass times acceleration sub g. Okay? So, hence the sum of external forces acting on a system of particles is equal to the total mass of the particles times the acceleration of its center of mass. So, ganun lang pala yung pag-solve natin sa external forces. I mean, external forces is how you determine that is you have to multiply or find the product of the mass of all mass of the particle or total mass of the particles times the acceleration of its center of mass g. So that's how you solve for external forces di. Okay, so I think that's the concept of equation of motion in a system or in a system of particles. So we did learn that to solve for our external forces that acting on our certain particle inside of our system is, yeah, the external all of the external forces acting on a particle is just equal to the total mass of the particle of the particles, no, times the acceleration of its center of mass sa ating whole system. Mass, yung acceleration ng g natin, i-multiply lang natin sa mass ng particle na to, plus mass ng particle na to, mass na. All of the particles mass inside of our system. So that's how you solve for your external forces acting on our system. Okay, so let's proceed for our part 4. No, the equations of motion using rectangular coordinates. Yan, medyo familiar na kayo dito kasi nga, we did discuss this coordinates sa natin previously lessons. Okay? So, as shown in the figure, when a particle moves relative to an inertial x, ayan, YZ frame of reference, the forces acting on a particle as well as its acceleration, and forces and acceleration can be expressed in terms of their I, J, K components. Basta, if we are going to deal with rectangular coordinates, automatically mag-expect na kayo na mayroong mga I, J, K components. So that's composes uh, the rectangular coordinates basically are JK components, IJK components. So then applying the equation of motion, ayan, to applying the equation of motion, we have internal forces is equals to mass times acceleration. So that will be each component, your I, J, K will have its magnitude to be all forces along X plus all forces along Y, all forces along Z is equals to the mass since scalar to. So, wala tong components, no, sa rectangular coordinates natin. So, acceleration, of course, that is a vector quantity. So, meron siyang acceleration along x, no, times I plus acceleration along y, j plus a or acceleration along z axis times k. So that's how you uh, say the equation of motion sa rectangular coordinates. Okay? So for equation 5.4.1 to be satisfied, their respective ijk components on the left side must equal to the corresponding components on the right side. Okay? So consequently, we may write the following three scalar equations. We have, ito na yung kumbaga equations, each component, no? In scalar na siya, in scalar quantity. So all force along x will be equal to the mass times the acceleration along x, of course, then y for acceleration, of course, along y, and same with along z axis. Okay, so there are some recommended procedure on how to analyze these kinds of problem using rectangular coordinates. So yeah, there are some procedures for analysis. So first you have to do is identify the given and unknowns in the problem. Okay, hindi naman kailangan talaga yon. So in solving problems, of course, we did learn na kailangan talaga identify muna natin yung given and then the required of the problem or basically the unknowns and the problem or yeah, kinakailangan ng problem na kailangan natin i-solve using those given na binigay. So establish an inertial coordinate system or rectangular coordinates. Okay? Establish na kayo mga inertial coordinate system niya sa natin sa particle natin kung may mga exertions ng mga forces uh, subjected no sa particle natin. Ganun. Next is yes, ito yung pinaka most important or essential talaga na kailangan yung gawin. So, you are going to draw a free body diagram based on established rectangular coordinates. FBD is very important because it provides a graphical representation that accounts for all the forces which act on the particle. Kumbaga, napaka-importante ng free body diagram in the sense na malalaman mo doon kung ano ba yung direction ng forces natin when we sum all of the forces. No, kung hindi mo siya kung hindi talaga mawasan na meron tayong makakalimutan if we're just going to imagine uh, siguro ito yung mukha ng provided diagram without drawing it uh, physically, no? Literally. Kailangan ito talagang i-draw para ano talaga, ma-picture out mo, kumbaga. No? Ma-represent mo graphically so that wala kang makakaligtaan, wala kang makakalimutan no, sa mga forces na nag-act sa sa particle mo. And you can also analyze na dito pala yung direction ng movement or emotion of your particle after you draw the free body diagram. It's clear. It's very important. So I'm requiring you all when uh, when you're involved to solve these kind of problems, of course in force and acceleration, especially in kinetics, you should provide me a free body diagram of that specific problem. Kung ano yun lang yung na-imagine nyo mo, then draw that one so that you can analyze it more, kumbaga, theoretically correct. Okay? So, establish the direction and sense of the particle's acceleration. Ayan, establish mo yung direction kung asan papunta yung acceleration in you. Provided by the problem. Okay? Ma-analyze mo na kasi yan kung saan pupunta yung acceleration mo after you solve or after you draw your free body diagram. Next, if the sense of direction is unknown, assume that it acts in the same direction as its positive inertial coordinate axis. Okay? Kung ano man yung direction ng ng acceleration mo, then assume na it acts always positive. Okay? And in our usual solving, no, we always assume na yung positive direction is for right, no, for right, then negative value for, or negative sets naman for the opposite or the left movement. And then, of course, we did also, yeah, usually we assume na positive yung pa-upward na mga movement or motion and negative yung opposite naman. Okay? I think that's the whole idea here. So if the force can be resolved directly from the FBD, apply the equation of motion in their scalar component form. Ayan. So meron ka ng na draw na FBD, then nalaman mo na, ito pala yung kailangan nating isolve. Then, yeah, you can solve it scalarly or, yeah, in the scalar component form, which is force is equals to mass times acceleration. Okay? So, if the problems involves three dimensions or coordinates, use Cartesian vector analysis to solve the problem. Yeah. I think that's self-explanatory, which is this one. No? Each kumbaga, each component is you're going to find its forces, ano ba yung mga forces nag-act sa particle mo, and x-axis, along x-axis, and y, and z, and so on. Okay? But some problems naman is kind of scarily lang. So, I think, hindi naman sa hinimin ko na di talaga kailangan ma-learn yung mga 3D or yeah, three-dimensionals na mga problems. Anyways, if the forces can be resolved directly from the FBD again, apply the equation of motion, and then if three-dimensional sa, ito yung gagamitin niya. Okay. So, if a moving particle or body contacts a rough surface, frictional equation should be used, which relates the frictional force F sub F and normal force N, acting at the surface of the contact by using the coefficient of kinetic friction. And I'll assume na lahat kayo, you already know this one because na take up naman to sa static and how to solve for the frictional force and the normal force. It's if yung particle or body natin is contact with rough surfaces, meron talaga yung friction. And if merong friction, may dalawang forces na again nag-exert automatically sa bottom of your or where the contact is. So meron siyang normal and frictional force. Unless stated sa problem na neglect the friction and all, then yeah, you can neglect all of those frictional force and normal force. But if kailangan talaga, if hindi minention na kailangan mong let's say assume na walang friction, then you have to consider these two, the frictional force and normal force. Okay? Now, if the particle or body is connected to an elastic spring, ito, another um, kinetic problem, there will be having negligible mass. The spring force, F sub S, can be related to the deformation of the spring by the equation F sub S is equals to K S. Kumbaga, ito yung spring factor ng meron kasi mga pero indicate naman yan kung ano ito lang value ng that kind of material or that kind of spring, no? Meron niyang ibibigay na spring factor, then multiply mo lang sa distance na deform or like na stretch or na compress ng ano mo spring, then multiply that one, then you can have your spring force. Okay, this is how you solve for spring force or F sub S. Okay, so we're and F sub S is spring force. Then K is the spring stiffness measured as a force per unit length. Diba? Per unit length, then kung i-multiply mo siya sa length, which is S, or stretch or compression, and is equal to the difference between the deformed length and undeformed length. Yan. Kumbaga, yung S mo is the difference between the deformed and undeformed. And if na-deform let's say uh, yung 5 meters long yung unstretched na spring mo, and then if yung problem states that you compress the spring until its length um, na attain ng spring mo after the compression is 3 meters na lang. So if the difference is the S, which is 2 meters, then multiply that into your spring stiffness, no? Basically, meron naman tong mga say provided naman yan sa problem kung ano ba yung spring stiffness ng material mo or that's that specific spring. So multiply mo lang again, multiply mo lang sa SNO. Then you can have your spring force. So another important formulas that you're going to learn is if velocity or position is required in a problem, determine the particle's acceleration first, no? Kailangan natin kung kailangan ng problem na what is the velocity after it pushed by this kind of or like this amount of force, no? So ano yung velocity niya after it pushed by that certain force? Then first you're going to do is you must determine the acceleration of the particle using the relation sa force and acceleration, which is force is equals to mass times acceleration. Then use kinematic equations na after that one. So we know that the kinematic equation derived from the instantaneous velocity and instantaneous acceleration and the relation between two. So if the acceleration is constant, then yeah, we can solve that using these formulas, kinematic formulas. So and yeah, if the problem require the distance or the baga, position of your particle after a force uh, after it was inserted by a certain force, then you use these formulas. If the acceleration is constant, then you can use this formula. Okay? So let's have an example for that. So, paano ba isolve yung mga ganyong problem? So, for example, 3. The 50 kilogram crate, shown in the figure, rests on a horizontal surface for which the coefficient of kinetic friction is mu k is equal 0.3, 0.3. Ito yung coefficient of kinetic friction ng floor or anyway, for and your crate. So if the crate is subjected to a 400 Newton towing force as shown, yan, kumbaga pull force, ano natin, determine the velocity of the crate in 3 seconds starting from rest. Yan, so, again, naka-ano pa lang natin, no? Naka-mention pa lang natin so, na what if kailangan ng problem na resolve yung kinematic, ano mo, mga motion, kinematic parameters mo. Then, this problem is perfectly right for that situation. So, first, basically the given muna. So, they have the figure is your P is equals to 400 N, and that is pulled from the horizontal 30 degrees. No? Mass is equals to the 50 kilogram, the mass of the crate, the coefficient friction. And so we have zero point 0.3, then again, the pull force is 400 Newton, and then the time is 3 seconds. And we are going to find the Fritz velocity in 3 seconds starting from the rest, from rest. Okay. Okay, so solution, first you have to going to construct the inertial coordinate system and free body diagram. So that's your first thing to do when solving these kind of problems. So inertial coordinate is wala nang iba, it will move right. It will move to the right kasi nga pinul siya to the right, then we can assume obviously that it will move to the right sense and our x-axis. So that will be our inertial coordinate system will be look like this. So our FBD naman will be look like this. So ayan, so all forces must be accounted to the FBD. So the weight of the crate, that's your first force, and the pulling force non-apply, and then the normal component of our friction and the friction force na nagre-resist the motion pa right. So, pa left siya. Always opposite sa direction ng force mo. Yung friction force. Okay? So, this is your FBD for the problem. So, let's proceed for the solving for the unknowns. Okay, so to solve for our weight, since mass lang yung binigay natin, so since we are going to account the forces that acts in our body, so since we are given with mass, then di pa siya enough yun. So kailangan we need to have the weight, or para Newton din yun, para uniform yung unit natin dito. So the given of the mass is 50 kilograms, so we just have to multiply that by the acceleration due to gravity, which is 9.81. So that will be 50 times 9.81. That will be equal to 490.5 Newton pa downward. Okay, so this is already here. So weight is equals to 490.5 downward. Okay, so the friction force that will be equal to mu sub k times the normal component of our force. So that will be 0.3, and see that since we don't know yet what is the value for our normal component, but to indicate the computed weight and F, or the frictional force in the FBD, ayan, eto, na na-indicate natin dito. So, kailangan na yung mga na solve na natin ng mga forces na before na wala pa siyang value. So, we need to indicate na, no? After we solve for the unknowns ng mga FBD, for example, yung wala dito is, or walang value dito sa FB natin is yung weight, yung frictional force, and the normal component. So next step natin is we are going to identify what are the say amount of these unknowns, no? So ginawa natin is we identify ano yung mga values ng mga unknowns natin. So we first identify the value of our weight. So that will be mass times gravity. Yan, so 490.5. So indicate natin. Okay? Next is the frictional force. That will be 0.3 times the normal. Yan, na-indicate na rin natin. So that is the second uh, say procedure para masolve ng problem na to. Next is solve the normal component and the acceleration using x component and y component of forces acting on the K. The acceleration A is assumed to act horizontally in the positive x direction. So A sub y is equal to 0. So walang y component na acceleration sa ano natin. And assume natin na horizontally lang siya component lang siya. Sa x component lang siya nag-move or yeah, wala siyang component sa y. So basically, para siyang, we're just solving here like how we solve for our projectile motion, di ba? No, meron siyang mga unknowns na masosolve using horizontal na manner or horizontal component, and meron din tayong masosolve na mga unknowns using vertical components. So basically parang projectile motion lang siya, so how to solve for this kind of problems, kumbaga, no? So applying equation of motion, we have all forces along x will be equal to the mass times acceleration along x. Okay, so that will be p times cosine 30, since the horizontal component of this one using trigonometry is 400 cosine 30. That will be the adjacent component of our inclined force, no? So it will be p times cosine 30 minus the another horizontal force, which is your friction force. That will be also the horizontal component. So since pa ano lang siya, direction mo na copy dito, so frictional force. What we are doing here is we account the forces that acts on the x-axis or pa-horizontal na mga forces. So we account that and we identify na dalawa lang yung horizontal forces na nag-act sa crate natin. So that will be the pulling force, and since inclined siya, we need to get the horizontal component of this one. So that will be t cosine 30 degrees. Minus, bakit minus is opposite siya sa positive sense natin na in-assume. That will be the right direction. So pa right siya or sa positive x-axis na sense. So if opposite siya, then automatically negative ang iyahang operation. So that will be friction force. Negative friction force is equals to the mass times acceleration. So, dyan. Okay na. So, substitute the values of the P and the friction force. That will be 400 cosine 30 degrees minus 0.3 times the normal component is equals to 50 kilograms times acceleration. Okay? So, that will be 400 cosine 30 minus 0.3 times the normal component over 50. Okay? So that will be equal to 6.928 minus 0.3 over 50 and C. Okay. So, ito yung na-solve natin sa horizontal component na mga forces natin sa crate. So, this is uh, na-identify natin na ito po daw yung acceleration natin in horizontal component. So, next is for the forces along y. Ano yung masasolve natin dito? No? So, forces along y is tatlo. The identified three forces na nag-act sa y-axis natin or along y-axis. That will be your weight, the vertical component of the force, P, and the normal component of our friction. So that would be positive P times sine 30, which is the vertical component of our pulling force, plus positive N sub C, since it acts upward, minus the weight, since, yeah, pa downward yung, ano niya, exertion. So that would be negative W is equals to mass times acceleration sub Y, or the acceleration along Y. So that will be 400 sine 30 degrees plus NC, that's unknown, then minus 490.5, that's our weight for the crate, is equals to 50 kilograms times 0, since we assume na walang vertical component ng acceleration dot. So that will be equal to 0. Okay? So that will be equal to N sub C is equals to 490.5 minus 400 times sine 30. And so bakit nangyari is we transpose the two terms to the right side. So this will become positive and this will become negative. So solving for our N sub C, that will be equal to 290.5 Newton. Then we can now solve for our acceleration using this solve N sub C. Now, to solve for our acceleration, we did discover na ito pala yung pag-solve sa acceleration using horizontal na mga forces. So that will be 6.928 minus 0.3 over 50 N sub C. Now, since we already have the value of our N sub C, substitute mo lang agad, then execute mo lang yung operation, then you can have for acceleration that will be equal to 5.185 meters per second squared. So note that the acceleration A is constant because the applied force P is constant. Force and acceleration are directly proportional. Then yeah, you can assume ano din na siya. If kung constant pala yung force natin, then we can assume safely na constant din yung acceleration natin since they are directly proportional. Okay. So thus we can use one of the formulas in rectilinear motion, constant acceleration, to solve for our required sa problem, which is your velocity. Then we already have the acceleration. We have also the time, no? Na required kung ilang velocity na yung na at ano yung velocity na experience ng crate after it pulled 400 Newton, 30 degrees from the horizontal. So ano yung velocity niya at 3 seconds, 'di ba? Yun yung mga kumbaga, what they call this, scenario ng problem natin. Ano yung mga yeah, given. Okay? So velocity using V is equals to V sub O plus AC times T. So don't complicate the problem by using some kinematic equation na maraming unknowns. Let's say hindi given yung distance of position. So ayos, wag mong gamitin yung may position na formula. For easier way is, yeah, you have to identify kung ano yung meron na given or wala. Then if yung formula na identify mo na meron ng mga unknowns, just like this one, your velocity is at rest is 0, your a sub c is, we already computed this one using the forces, no, or equation of motion, times the time, since we also given na 3 seconds yung time, what is the velocity? So solving for that, v sub o is equals to 0 since it's starting from rest. Then the condition is 3 seconds. Ano yung velocity ng crate natin after 3 seconds it pulled 400 Newton 30 degrees horizontally. So ito yung mangyayari. So ito yung velocity na may experience ng crate mo. So that will be v is equals to 0 plus 5.185 meters per second squared times 3 seconds. So that will be equal to 15.56 meters per second. So that's how you solve, kumbaga, how to solve the kinematic problem when it is we are now considering the force, no, that uh, it exerting on our, yeah, a certain body or particle. So that's how you solve for it. Again, to summarize for the solution for this one is, first you since we are required for the velocity, that is kinematics problem. So we need to get the acceleration of our body after it pulled 400 newton 30 degrees from the horizontal. So we need acceleration. So pag solve natin sa acceleration, uh, horizontally, mga horizontal forces, we account all of the horizontal forces, then we account the acceleration there since horizontal lang naman nag-act yung acceleration natin. So we did discover na to solve for our acceleration. Now, we're not done yet kasi nga meron siyang n sub c. We don't know the value of n sub c. No? So, we now account the forces, all of the forces na nag-act along y-axis or mga vertical forces na nag-act sa curve natin. Then, after we solve that, na-solve natin yung n sub c. Then, after we solve the n sub c or the normal component of the friction, nakuha na natin yung acceleration. Then after we solve the acceleration, then we use a kinematic formula. Now V is equals to V sub O plus A sub C times T. Then, yeah, substitute na lang yung mga values, then solve the operation. And you can have for your final answer. So that's how you solve this kind of problems na kinetics, involving kinematics. So another example is this one. Example 4. If the condition is meron na siyang spring. So, paano ba i-solve to? Okay? This a smooth 2 kilogram collar shown in the figure is attached to a spring. Yeah. A smooth 2 kilogram collar shown in the figure is attached to a spring having a stiffness K is equals to 3 Newton per meter. Okay? And stretched length of the spring is 0.75 meters. So if the collar is released from rest at A, and determine its acceleration and the normal force of the rod on the collar at the instant y is equals to 1 meters. Okay, so how to solve this one? So first, given muna tayo. So the figure, ito yung figure niya. Then the mass of the collar, 2 kilograms. K is equals, or the stiffness of the spring is zero point 0.3 Newton per meter. The length of AB, ay ko, 0.75, and Y is equals to 1 meter. Okay, these are the conditions or given sa problem. How to solve for our required here is dalawa. The acceleration of the rod on the collar at an instant y is equals to 1 meter, and the normal force sa rod on the collar at an instant y is equals to 1 meter. So solution, again, yeah, obviously, draw the free body diagram and the inertial coordinate system. So the movement of our collar will be onward. Kung saan yung magmo-move talaga is yun, doon din doon din yung positive sense ng ano natin and how we solve for this problem. So that's your inertial coordinate system. So for our FBD, for our collar, that will be the weight. Ito, the downward force is the weight of the collar itself. The normal force na cause sa spring natin. And the F, or the force is spring force dito. Okay? Ito yung free body diagram ng color natin. So, tatlo lang. So, this your normal component or the normal force, the weight, and the spring force. Okay? So, the color is assumed to be accelerating downward. So, the acceleration of the next component, a sub x, is 0. Di ba? Since mo accelerate lang, no, wala man siya, wala siyang movement horizontally. So, vertically lang talaga siya mag-move kasi nga collar eh. Tapos, pa-vertical yung ano natin, rod. So, yeah. Obviously, we can assume na, or we can actually predict, or we actually know na walang x component yung acceleration natin dito. So, we will set downward direction as positive for y component. Since ganun yung movement ng collar natin after it released. Okay, so apply equations of motion. So all forces along x will be equal to the mass times acceleration along x. So forces that acts horizontally or mga forces acts at x-axis, that will be your the normal force and the what do you call this? The x component of our spring force. Okay, so that will be negative n sub c since pa left yung movement niya. And we assume here na for right is positive sense. That will be negative n sub c or the normal force plus the spring force cosine theta. Y cosine theta is the adjacent force, so that will be the x component of the spring force. Okay, is equals to the mass times the acceleration along x will be zero since we said na walang x component ang acceleration natin since the collar will be moving upward or downward lang. Okay, so that will be n sub c is equal to f or the spring force cosine theta. So here's how you solve for our normal component. This is the second requirement nata. Yeah, normal force. No, that will be solved by multiplying the spring force times the cosine theta. So all forces along y naman, that will be equal to mass times acceleration along y. So that will be forces that acts along y is the weight and the further component of the spring force. So that will be weight minus spring force sine theta is equals to 2 kilograms times acceleration. Okay. So ito yung y component natin. So that will be 2 kilograms times 9.81. So that's how you solve for our weight. Minus the spring force sine theta is equals to 2a. So a is equals to 19.62 Newton minus F or the spring force sine theta over 2. So spring force and angle theta. So paano ba to solve itong mga spring force natin? So that will be uh, F sub S is equals to K times S. Then where K is equals to 3 Newton per meter, that will be S is equals to stretched length minus unstretched length. Okay. So the unstretched is CB. And then stretched or no, the stretch is the CB. Ayan. Ito yung stretch niya. Okay? Tapos, the unstretched naman is AB. So, ito yung initial na length ng natin, spring, nung yung collar is napa sa ibabaw. Now, when we move the collar to the point sa C, our spring was stretched. No? So, ito yung form niya na biglang humaba. Okay? So, that will be equal to, using the Pythagorean theorem, that will be square root of y squared plus 0.75 squared minus 0.75 meters. So, this is the stretch length. How you solve for the stretch length? So, Pythagorean theorem is c squared is equals to a squared plus b squared. Okay? So that will be y squared. That will be 1 actually sa conditions of problem. Tapos yung natin dito, b squared, it will be 0.75 squared minus the unstretched length. So ito yung unstretched length niya is 0.75. Ito, given sa problem. Ito yung unstretched length niya. So when y is equals to 1, therefore your s will be equal to square root of 1 meter squared plus 0.75 squared minus 75. So that will be equal to 0.5. So ang length pala dito for our say S for our for solving for our spring force will be equal to K times S. So this is our S, which is the difference between the stretch and the unstretched length. So that will be S is equals to 0.5. Then we can solve for our spring force to be, ayan, so spring force is equals to 3 per meter times 0.5. This is your S. We have already solved that one. So therefore, your spring force will be equal now to 1.5 Newton. And for our theta, will be tangent theta is equals to y over 0.75. Since, ayan, it's adjacent over opposite or opposite over adjacent. Yeah, ito pala yung ano natin, yung theta natin dito. That will be opposite over adjacent. So that will be y over 0.75. Then arctan mo na lang. Ayan. Arctan or theta is equals to arctan 1 over 0.75 since this is the condition when uh, y is equals to 1 meter. So our theta will be equal to 53.13. So nasolve na natin yung spring force and the angle. Then we can now proceed for solving for our normal component. And also the acceleration, of course. Now, A is equals to 19.62 Newton minus spring force sine theta over 2. We already have these values, no? That will be 19.62 Newton minus 1.5 Newton times the sine 53.13 degrees over 2. So your acceleration di will be equal to 9.21 meters per second squared. And also for our normal force, we already identified how to solve for our normal force using the horizontal forces. That will be normal force is equals to spring force times cosine theta, and we already have this unknowns, no? So just substitute the values. That will be equal to 1.5 Newton times cosine 53.13 degrees. So that will be n sub c is equals to 0.90 Newton. So, yeah, so more important, our highlight ng mga ano dito is you should know how to solve for your spring force, no? That will be K times S. Then free body diagram ng color natin since we already focused for this one. And then kumbaga yung idea in solving these kind of problems is first you draw for your FPP and then solve for the unknowns using the vertical component of the forces or vertical forces nag-act sa ano mo, makakuha ka doon ng mga equations. Then if kulang yung sa horizontal, then punta ka sa vertical ng mga forces, then equate mo lang doon sa m times a, no? And that's your equation of motion. Then solve for the unknowns, then you can have your required. Okay, so I think that's all for equation of motion in rectangular coordinates. So how about the normal and tangential coordinates? So ano naman to? So meron yung mga uh, what if yung force na apply mo will cause the object to move in a curve path. So meron na siyang normal components acceleration mo. Hindi lang palagi tangential since most of the problems in rectangular coordinates, magagamit mo lang yon if your body or your particle moves in a rectilinear straight line lang. So, uh, walang normal na component na acceleration na nag-act sa particle mo. So, what if your object is moving in a curved path? So, ayun nga, nag-exist na si normal acceleration. So, we need to account those also. So that we can also solve for the actual forces, acceleration, and all of the unknowns that is exerting on our particle. Then, how to solve them? Let's proceed for part 5. So, equation of motion, normal and tangential coordinate, is more likely familiar na sa inyo. Kasi nga, natakol na natin to sa mga curve ng mga lesson natin. Yung curvilinear motion and your rotation about the fixed axis. And yeah, we did really discover na meron talagang normal and tangential coordinates if our body is moving in a curve or yeah, circular motion. So, nag-exist ng mga to. Okay, so as shown in the figure, when a particle moves along a curved path, that's what I'm saying, which is known, the equation of motion for the particle may be written in tangential, normal, and binormal direction. So tatlo na nangyayari dito, class. So there are three directions na mapupunta yung particle mo. Meron mga component. That would be your tangential, normal, and binormal. Dami ng mga directions, okay? So, note that there is no motion of the particle in binormal direction. Why? Since the particle is constrained to move along the path. So, if along the path, then walang binormal na. See, a figure class is, this is your tangential component, your normal component that will always be um, directed to the center of our curve, no? Towards the center of the cave, or the cave naman, concavity of our curve path, and then the binormal is pa-upward na mga ano. So, sabi dito that no motion of the particle in binormal direction since the particle is constrained to move along the path. Okay? Along the path. Okay? So, wala na siya binormal na ano. Pero sa ano talaga, kung hindi sa constraint sa path talaga niya, or may mga tendency na move siya hindi with respect to your curve path na, or any path, is meron siyang binormal direction, of course. So apply equation of motion, we have, and internal all forces exerting to the body will be equal to mass times acceleration. This is our equations of motion, and we already know why we came at this motion or equation of motion. So that will be all forces on the tangential component, that will be force times u. This is the unit vector of our tangential, plus the normal component and the binormal component is equals to uh, mass times the acceleration or tangential acceleration plus the normal acceleration. Okay, normal components. And again, we did learn na walang motion na nangyayari sa binormal. And kung walang motion, walang acceleration. And kung walang acceleration, wala din tayong component dito for binormal. I'm so sorry for binormal. Anyways, the equation above is satisfied, yan, provided that, yan, and all forces along tangential direction will be equal to the mass times tangential component of acceleration. Okay? Or A sub t. And for our f of n, or all forces of f sub n will be equal to m times a, or times the normal acceleration, or the normal component of acceleration. And for our f b naman, since wala siyang acceleration, that will be equal to 0. Okay, so recall from module number 3 in lesson 3.4 about tangential and normal components of acceleration and how to solve them. Remember, so to solve for our tangential components of acceleration, no, the acceleration will equal to a sub t is equals to dv over dt lang. So that will be the time rate of change in the magnitude of the velocity. In the magnitude of the velocity. Okay? Always take note that if we're talking about tangential component, always, yeah, the time rate of change in the magnitude, always the magnitude of the velocity ang concern for the tangential component. Okay? For the normal component naman, or before we talk about that, so if all forces along tangential component acts in the direction of motion, the particle's speed will increase. Whereas if it acts in opposite direction, the particle will slow down. So same lang, parang same concept for the previous lessons. If yung force na nag-act sa motion natin is, the direction of the motion is positive siya, or the speed of the particles is increasing, or yeah, accelerating, kumbaga, basically. And if acts in opposite direction, then decelerating siya. Or ning and decrease ang iyahang velocity. Okay? So likewise, the normal component of acceleration, a sub m equal to v squared over rho, represents the time rate of change in the velocity's direction. So direction naman sa normal component. Okay? So if it caused by the all forces along normal component, no, which always acts in a positive n direction or towards the path center of curvature or the center of the curve. Yan. So that will be the positive n direction. Okay? For this reason, forces in the normal component is often referred to as the centripetal force or the center-seeking force. So, ayun nga, dito na kumbaga nabuo yung centripetal force since it always act on uh, it always act towards the center of the curvature. Kasi nga, if you uh, been gonna observe na pag sumasakay kayo ng bus, and then if may curve na daan, and then if the bus is running kind of di naman sa mas mabilis kasi nga curve na, you must say slow down. So, mapapansin nyo is your body will kind of will go like move siya pa opposite sa pag-curve niya. Kumbaga, parang may magpupull sa inyo pa. Kung yung curve is how to illustrate that one. If let's say yung curve na daan is pa ganon, di ba? O curve na daan is ganon. And then you're actually the bus is here. You're actually experiencing a force, kunwari ikaw to. And what we're saying about centrifugal force or the normal component, no, of the force is that meron ka ma-experience na force na papunta dito. No? Kasi nga, ito yung tinatawag na normal force natin. Kumbaga, may magpupull towards the center of the curvature. Since ito yung, let's say, ito yung center of the curvature, then meron ka ma-experience na force na parang hinihila ka pa gantong direction. So uh, that's actually the centripetal force that you are experiencing now. After you curve, you daan to the curve, and then I'm just about the whole idea here is in real life or in the experience in your is that theoretically speaking is that that's your centripetal force. Ang dami ko sinasabi. Basta yan lang sa class. So another procedure for analysis in normal and tangential components and solving this kind of problems is first is when a problem involves the motion of a particle along a known curved path, normal and binormal and tangential components should be used for analysis since the acceleration components can be readily formulated. Again, tangential, normal and tangential na coordinates in solving the kinetics particle or the kinetics of the particle. Siyempre gagamitin natin yung normal and magagamit lang siya kung curve path yung motion ng particle natin. Okay? So again, identify the given and unknowns in the problem. Again, first you must do is, of course, identify kung curve ba yung motion natin sa problem na to. And if curve, proceed to the normal tangential. After you identified kung ano yung kumbaga motion ng natin, straight line lang ba siya, then gamitin mo yung rectangular na equation of motion. Then if curve, then dito ka sa normal and tangential coordinates na problem or na way of solving some problem. Next is identify the given and announce the problem. That's basically, obviously, included talaga siya in solving this kind of problem, di ba? Then establish inertial coordinate system and TV of the particle. Next is draw the free body diagram, always, to graphically show the forces acting on the particle. Next is the particle's normal acceleration. or A sub n always acts in a positive n direction or toward the path's center of curvature. Okay, always take note of that one. Now, if the direction of tangential acceleration A sub t is unknown, assume it acts in the positive t direction. Okay? And the positive t direction, kung hindi mo talaga known na, dito yun. Ito yung direction ng tangential component natin. Dito yung positive. Then, if di siya given by the problem, then you can safely assume na it acts in a positive t direction, which is tangent, tangent to the motion of the particle or the body. So there is no acceleration on binormal b direction. Always take note of that. Then apply the equation of motion to solve the normal, tangential, and or binomial component of force. Okay? So, ito yung kumbaga, basically ito yon. Kumbaga, ito yung equations of motion sa normal and tangential coordinates. Ito yun. Ito yung gagamitin mo. Okay? So, where scalarly, that will be equal to all force along uh, tangent component will be m times a sub t. That will be tangential component of acceleration. Another is all forces along the normal component is equals to the mass times the normal component of acceleration. Then lastly, the all forces along the binormal component is equals to zero since walang motion sa nangyayari sa binormal or walang direksyon na papunta doon sa particle. So can safely equate that to zero. Okay. So to solve for the normal and tangential components of acceleration, use kinematic equations. Ito lang yung kumbaga pag-solve sa a sub t. Okay? And then for a sub n, it will be v squared over rho. Okay? So if the path is defined as a function, the radius of curvature rho at the point where the particle is located can be obtained using the formula na ito. If a function yung path natin. Okay? Kasi mostly, the problem is meron na talagang given na mga radius ng radius ng curve natin sa problem, then yun yung raw automatically. But if function, ito yung gagamit mo na formula. That will be 1 plus first time derivative ng function mo. Okay? Square that one and quantity raised to 3 halves all over the second time derivative of your function y. Okay, that's how we solve for your law. Okay, so let's have an example para ma-relate natin or ma-apply natin yung mga concepts na na-learn natin in normal and tangential coordinates. So yeah. So the 3 kilogram disc B is attached to the end of a curve as shown in the figure. Yan. The other end of the cord is attached to a ball and socket joint, ito, located at the center of the platform. If the platform rotates rapidly and the disc is placed on it and released from rest is as shown, ayan, determine the time it takes for the disc to reach a speed great enough to break the cord. Okay? The maximum tension the cord can sustain is 100 Newton. And the coefficient kinetic friction between the disc and platform is mu sub k is equals to 0.1. So, ang problema natin dito is what is the maximum, what is the uh, speed na kailangan na ma-experience ng disc natin para ma-break yung cord natin. Okay? And then we are given the tension of the cord to, of course, solve for the unknown. Okay? So, first thing to do before the given, again, is identify kung ano yung motion dito. And we already know na pa-curve or pa-circular yung motion niya. So, we can use the normal and tangential component of the tangential coordinates. here. So equation of motion, normal and tangential coordinates. Okay, so for the given is these are your given the figure, and so the radius or the rho will be equal to 1 meter, mu sub k or the coefficient of friction zero point 0.1, the tension of the cord 100 newton or the maximum tension that can uh, masustain sa imuhang cord will be 100 newton, and then the mass of the disc is 3 kilograms. Okay, the required is the time it takes for the disc to reach a speed great enough to break the cord. Yeah. Time kumbaga kinahanap natin dito. So, first is construct the free body diagram to show the forces or reaction acts on the disc. Ayan, so, uh, kumbaga, like, combine lang to ng inertial coordinate and then the free body diagram. Okay, your binormal, your tangential, and your normal, and this is your body or the particle or the disc basically. So meron siyang force sa friction force, yan, na meron siyang weight, then the normal since merong friction, and the tension. Okay, ito yung mga forces na nag-a-act sa disc natin. Yan, again, your friction force, okay, the normal force, the tension sa cord, and then the weight of the disc. So solve for the weight and the friction force and indicate it in the FBD. Okay? Since wala tayong mga values dito, so we need to indicate the values of this one para ma-analyze natin ng clearly. So we have weight of the disk rather will be equal to mass times the gravitational acceleration, that will be 3 kilograms to 9.81 meters per second squared. So that will be equal to 29.43 Newton. For the friction force, that will be mu, okay? That will be times ND is equal to zero point 0.1 N sub D, or the normal force of the disk. So friction force is equal to zero point 0.1 N sub D. Note that the maximum tension the cord can sustain is T sub max is equal to 100 Newton. Okay? So to solve for T, we must first obtain the values of N sub D, A sub T, and the critical speed or the velocity of the disk needed to break the cord by applying equations of motion. Ayan. So, equation of motion, kailangan natin dito. So, for tangential component, ito yon. Okay, what are the forces na nag-act sa tangential component natin? Okay, ang tricky kasi dito class is we need to um, assign yung mga forces kung asan siya nag-act sa saan siya nag-act, sa binormal ba siya, sa ano ba siya, sa tangential ba siya na axis or sa normal axis ba siya. Di katulad ng na rectangular is you have two only, di ba? Dalawa lang yung i-consider mo doon, yung mga forces na nag-act sa x-axis and forces na nag-act sa y-axis. Now, sa normal and tangential coordinates is different. Okay? Meron kang tatlong axis na kailangan mong i-consider. That will be binormal axis, instead of using x and y axis or along x and y axis, dito sa normal at tangential is along the binormal axis, along the tangential axis, and along the normal axis. So, medyo marami dito na consider na mga axis. So, again, first is the tangential component. So, ano yung mga forces na nasa sa tangential component natin? So, it will be all forces along the tangential component or coordinate be equal to mass times the tangential component of the acceleration. That will be the friction force only. No? Ito lang yung nag-act sa ano mo, tangential component. Okay? So that will be friction force is equal to mass of the disk times the acceleration tangential component of the acceleration. So that will be 0.1 ND, 3 kilograms, and ano pa yung acceleration or tangential component of the acceleration. So A sub T is equal to 0.1 N sub D, that's not ND, that's 0.1 N sub D over 3. Okay? So for normal component naman ay yung mga forces na nag-act sa normal component, and we can see that the only force that acts on the normal component of our disk is only the tension of the cord. So that will be the T max is equals to mass of the disk times the normal component of the acceleration. So that would be 100 Newton is equals to 3 kilograms critical speed squared over the radius. Okay. So that will be 100 is equals to 3 times the critical speed squared over 1 meter, since 1 meter yung radius natin na given sa problem. Okay, so that will be the critical speed will be equal to 5.774 meters per second squared. Okay? So meron na tayong critical speed natin dito. So meron tayong velocity. Wala tayong acceleration na kailangan pa natin ng acceleration to solve for our time. Okay? So for binormal component, ano yung masasolve natin sa binormal component? So meron tayong weight and the normal force. So that will be upward force will be the positive manner. So that will be all forces along the binormal axis will be equal to zero, since walang acceleration or walang hindi doon, walang direction yung sa walang motion sa direction ng binormal na axis. Okay? So that will be equal to zero. Now, the only forces na nag-act sa binormal axis is the weight and the normal normal component or the normal force. Okay, so basically masosolve na natin directly yung ends of dito. So you just transpose and equal lang pala yung weight and the normal force sa disk na nag-exert sa disk. Okay? So that will be ends of d is equals to 29.43 Newton. So substitute the value of n sub d sa equation 1 so that we can solve for our acceleration. So that will be zero point 0.1 times 29.43 Newton over 3. So our acceleration or the tangential component of the acceleration be equal to 0.981 meters per second squared. Okay? So note that the tangential component of acceleration is constant. Thus, we can use the kinematic equation V is equals to V sub O plus AT sub C times time to solve for the time needed to break the chord. Ayan. So, solving with critical velocity. Okay, parang nag-interconnect siya class. Kumbaga, na-relate natin yung the maximum tension ng chord sa pag-solve natin sa critical speed. So, kumbaga, ito yung critical speed na kinakailangan or kailangan natin na critical speed para ma-break natin yung um, ma-break natin yung chord. And then, in this relation naman, we can determine na sa anong oras or when will be the time na mabe-break yung chord. So, kailangan lang natin is the velocity, na critical velocity. Then, equate natin dun sa acceleration na nakukuha natin. So, this will be the exact formula that we're going to use, di ba? So, that will be, the critical speed is equals to V sub O plus A sub T sub C times time. And the problem also given na at rest initially, yung this natin before it rotates, no? So, that will be equal to zero, yung initial velocity. So, therefore, substituting the value and solving for our time, that will be equal to 5.886 seconds or approximately equal to 5.89 seconds. So, this is the time needed to break the chord or eventually na mababreak yung cord. So, after 6 seconds, approximately, mapuputol na yung cord nyo and then the disc will be swing out or yeah, wala na siya sa system natin. So, again, this is our time needed to break the cord. So, to summarize this solution is that first, dapat na-identify natin kung ano yung um, say motion ng system natin. So we did discover na pa-rotation or basically nag-curve yung path natin. So we are going to use the normal and tangential coordinates system. So after that, after natin na ma-identify, then draw the free body diagram and the inertial coordinate diagram. And this is we uh, nakuha natin, di ba? Ito yung na-draw natin. And take note also class that again, the normal and tangential the coordinates is na meron siyang tatlong component. Okay? Unlike sa rectangular is xy component lang yung nandun. But in the normal and tangential, tatlo na siya. Okay? Your binormal, your tangential, and the normal. Okay? So after we draw this one, we solve the unknowns on each axis, di ba? Sa tangential axis, tangential component, we did discover or we did determine the friction force. Since this is not given by the problem, we are only given no sa coefficient of friction. Then from this, we did also relate the value for our acceleration no sa disk no. So sa normal component naman na-solve natin doon yung critical speed na kailangan natin to break this chord, di ba? So na-solve natin doon yung velocity or critical speed na kailangan. And then sa binormal naman, nakuha natin doon yung normal, no? Normal force. And then the normal force na na-solve natin, ginamit naman natin to solve for the acceleration. No? Now, since we already have the acceleration and velocity from the normal component na na-solve natin, then we can use the kinematic equation, then substitute the value that we have already solved from each components, then you can solve for the time needed to break the chord. So I think that's how you solve for our or problems involving normal and tangential coordinates. I think that's all for this one. Okay. So class for the next week will be your first long examination, and I'm informing you earlier so that you get prepared. No? Again, ang coverage ng exam natin is from Module 1 to Module 5. The uh, deduction of dynamics to this one, the kinetics of particle force and acceleration. And I think that's all for this lesson. And I hope you did learn something from this, and you can apply on solving for your you already you learned some important concepts, formulas, and ideas solved for your problem set number 3. And if you have questions and concerns, just contact me. And I hope you did again learn something from this, and see you next lecture video.